This video is for Chapter 8, Section 5, and it's all about angles of elevation and depression. This is hopefully going to be a short video as we are just introducing the simple idea of angles of elevation and depression, and then we're going to use them to expand the work that we can do with trigonometry. So an angle of elevation and depression, the first thing is not so much to define them, but to look at them and see them and come up with your own definition. In the picture I have here off to the left side of the board, we have a person standing at the edge of a lake. Flying above is a bird and down in the water is a fish. So there are four angles that are on this picture. Angle 1, which represents the angle that the person has to look up to see the bird, is an angle of elevation from the person to the bird. The reason it's an angle of elevation is because the person's eyes would look horizontally and then elevate up to see the bird. As if I use this as my horizontal and I look up. How many degrees did I have to angle up in order to see the bird? This is an angle of elevation. Now the reverse happens when the person begins to look down to see the fish. They're looking forward and they tilt their head down to look at the fish. Now that creates an angle of depression. So angle 3 is an angle of depression from person to fish. It is depressing. Okay. Now, we can also talk about angle 2, although it's not written on the board, but you can write it down. Angle 2 is an angle of depression from bird to person. And angle 4 can be described as an angle of elevation from fish to person. It is important that we pay attention to what the angles are elevating to and what they are elevating from, or depressing to and depressing from. So, angle 1 is elevation from person up to bird. 3 is depression from person down to fish. It is true that in this picture, angle 1 and angle 2 are congruent because they are alternate interior angles created by two horizontal lines. So, an angle of elevation from A to B is always congruent to angle of depression from B to A. Okay, the last thing I'm going to point out is that angles of elevation and depression must always be created with a horizontal line. Again, I'll use the ruler. If I create a horizontal line, I am able to depress or I'm able to elevate. However, if I use a vertical line and someone was to say, let's depress this angle, I don't know which way to go. That's not depressing, that's not, no. Horizontal, you are able to elevate, you are able to depress. Let's take a look at how this works in certain problems and in the context of what we're going to do with this unit. So we're going to want to have our calculator and we're going to want to have paper to draw these pictures on. So a bird in a tree spots a worm at a 32-degree angle of depression. If the bird is on a branch 25 feet high, how far must it fly to get the worm? So I'm a terrible artist, but here's my tree with the little bird. And there's the worm. The bird spots the worm, and the bird is sitting up in a tree 25 feet high. What we're going to do here is create a right triangle so we can work with the material that we have for this unit. But we have to put the 32-degree angle into this picture. The most common mistake, very important right here, is that people put 32 degrees here. This is not an angle of depression. It is not touching a horizontal line. We must add a horizontal line to this picture. Put 32 degrees here, and then recognize one of two things. Either we create this as being a 58-degree angle using 32 plus 58 equals 90, or we use the alternate interior angle and put 32 degrees there, because the angle of depression from the bird to the worm is the same as the worm to the bird's elevation. Now, I am trying to find x. This is important. It says how far must it fly? This is not x. The bird has to fly like this. Now, at this point, I have a right triangle, I have the opposite side, and I have the hypotenuse. I can now refer to my trig to set up the problem. The sine of 32 degrees is equal to the opposite side, 25 over x. This is the final case, the toughest case for us, where we multiply by x on both sides. X sine 32 is equal to 25, and we divide by the sine of 32 degrees in order to find out what x is. We take our calculator, 25 divided by sine 32, and we find out it's approximately 47 feet. So we'll put in approximately 47, and we would want to answer probably with a sentence. We were asked a question, so we should probably say, the bird must fly 47 feet to get breakfast. Okay, it would probably be 47 feet in order to get the worm, but I thought it's probably going to eat the worm anyway. All right, so there's one example of angle of depression. Absolutely critical example. The fact that the original angle of depression did not show up in the actual triangle. We used the alternate interior angle in order to create our triangle. Now our next one. A worker measures the angle of elevation from the top of one building to the top of another building as 15 degrees. If the shorter building is, and that's not really building, is 200 feet tall, and the buildings are 100 feet apart, how tall is the second building? Of course, critical here is to get the picture right. So I'm going to draw my first building, and this is the building that is 200 feet tall. And then I have a second building, which is taller. And the buildings are 100 feet apart, and the angle of elevation, my picture is not super large, but the angle of elevation from the top of one building to the top of the other is 15 degrees. So that becomes 15 right here. Hopefully we can see this. 15 degrees is my angle of elevation. Now what's going to happen is I'm going to move this rectangle right here, the 100, up to right there. And I'm going to get rid of this window and say what I can find is x. I can't find how tall the large building is, but I can find x. And x represents how much taller the tall building is compared to the shorter building. So my answer is eventually going to be that the tall building is going to be 200 here plus x. Okay, so now I'm going to go find x. I've got my angle of elevation. It's with the horizontal. The guy looks up to the top building. This looks like I have the opposite side, the adjacent side. I don't have the hypotenuse. So this is a tangent problem of 15 degrees equals x over 100, opposite over adjacent. This would be case number 1, where all we have to do is multiply by 100 on both sides. And so we go to our calculator, 100 times the tangent of 15 degrees. We hit equal, and we find out that it is 26.8. So approximately 26.8 is how much taller the second building is. So it's not that much taller than it, with only a 15 degree angle of elevation there. So we can put here 26.8 represents the difference. So we're going to put 200 plus 26.8, and our final answer is the second building is 226.8 feet tall. Those are our two examples of how to use angles of elevation and depression. Again, the only thing, it must be created with a horizontal line. From there, we turn it into our right triangle problems and use trigonometry. That's it for Chapter 8, Section 5. You can begin working on that assignment.